Alright, so today's 4.2, solving quadratics by graphing. Just a reminder that 4.1 is due tonight if you haven't already submitted it. And then, of course, we have that short quiz, which is due Sunday. So, an important concept for you to understand in this course is we use these words somewhat interchangeably. So when we talk about a quadratic, we use these words a lot. Zeros are basically values that you can plug into your function that would output as a zero, meaning that it crosses the x-axis. A root or a solution are the values for which your equation crosses the x-axis. So for example, x equals 1 and x equals 2. Those are roots and or solutions. And then factors are basically how you would write your quadratic in factored form, and you would set these equal to 0 to obtain the roots or solutions. And then x-intercepts are like writing the root or solution, but you write it in a coordinate pair instead of by itself, so you write like 1, 0 and 2, 0. So a number and type of quadratic solutions are roots. All quadratics have two solutions, sometimes they are repeated, and all quadratics graphs reveal something about those solutions. So two distinct real roots means that we touch the x-axis two separate times on two different locations, okay? And that means we have two x-intercepts or two distinct real roots. One distinct real solution means that you cross the x-axis only one time, and when this happens, it means that there are two solutions of the same exact type. So like x equals 4 and x equals 4 came up twice. And it also means that your solution is also your vertex. So does everyone see how this is also the vertex of this quadratic? And then the last type is when we have two imaginary solutions, which means we have no real roots, and that's when we don't cross the x-axis at all. Now be very careful with this one, because that means that the way that this is positioned, you can see that it will never cross the x-axis. Obviously, there are some cases where you may graph it and it will eventually cross the x-axis, but as you can see here, this one will never, okay? All right, so for this portion, we are going to go through, identify the number of solutions, and then what they are. And as you can see, they're asking us to do it in different ways, so I'm going to be following that circular chart on the previous slide. That will be telling us what type of format they're looking for. So, how many solutions do we have to this one?
1.
Good. And they want us to write it in the form of 0, so they want us to write f of, what is the solution again? 3 is equal to 0. And that could also be written in the form x equals 0. So this is what we call function notation, okay? And in function notation, you put the x value on the inside and the y value out here on the outside. So does anyone have any questions for me about number 1? All right. The next one we're going to be doing is number 2. And number 2, how many solutions do we have?
2.
Good. And they want us to write it in the form of roots, so x equals. So what are our two solutions?
1 and 2.
Good, 1 and 2. Does everyone see why they are 1 and 2 there? It's where they cross the x-axis. All right. Moving on. If I'm going too quickly, just let me know. Number 3. How many solutions does number 3 have?
2.
Good. And what are they?
-6, -1.
Good. So we're going to write it in the form of x-intercepts. As you can see on your wheel, they want you to write it as an ordered pair. So -6, 0, and -1, 0. Any questions so far? All right. How many real solutions does this one have?
0.
Good. The solutions are imaginary. So we have a whole section of this class where we talk about imaginary numbers. So we're just going to keep it really simple now. If it doesn't cross the x-axis, it's imaginary. We'll learn more about what that is in the future. Any questions? Okay. How many solutions for this one, number 5?
2.
Good. And what are they?
0 and 4.
Good. Does anyone have any questions? Okay. How many solutions for 6?
1.
And what is it?
0.
0. Alright, so how does everyone feel about 1 through 6? Are we good to move on to the next slide? Alright. Yeah.
I think you accidentally did solutions instead of zeros for number 5.
Oh, I see. Yeah, that's okay, but yeah, you're right. You could write it as f of 0 is equal to 0, and f of 4 is equal to 0 too. But good point. Good noticing that. So yeah, if you want to write it in the form of zeros, alright. So let's look at number 7. So you can go ahead and graph these by hand, but I'm going to be using Desmos today. You're encouraged to use Desmos as needed on the homework as well. And it does work on a mobile phone, so there actually is an app in the App Store that you can get as well. So if we look at how I graphed it, I go to the graph and then I click this button, which gives me my table. I can manipulate what X values I want them to output for me.
Wait, which button do you click again?
You click this little button and then you click the table.
Okay.
And it gives you a table. It's really convenient. So you can change these X values to anything you want and it will give you that value. So what we're going to do here is we're going to go ahead and plot the points that I just found. So we have a point at -2, 0. We have a point at -1, -2.5. So that's somewhere between the -2 and the 3. We have a point at -4, sorry. We have a point at 1, -4.5. So way down here. And we also have a point at 2, -4. So before I give any more values, I want to kind of give you a conceptual understanding of this, because this is really important for all different types of exams and stuff that you may take. Now that we see what this shape generally looks like, can anybody tell me what the axis of symmetry here is?
1.
X equals 1. Does everybody see that axis of symmetry right there? Does everyone see how we were able to identify it? Because it's the point at which the points start flipping around and changing. So with that being said, you can use the symmetry property to actually find the points on the other side. So see how here 1, 2, 1, 2, and we know we have a point over here. And we know we have a point 1, 2, 3, 1, 2, 3. So does everybody see how I got those 2 points using symmetry property? So we can then connect them and make a picture of our graph. And before we go into answering the questions, I just want to explain a little bit here. So this is a property about quadratics. What do you notice about the distance from this 0 to the axis of symmetry and the other 0 to the axis of symmetry? What do you notice about these two distances? Good, they are equidistant. So the whole idea is the axis of symmetry will always be equidistant to the two zeros. Does everyone see that? So if you see that it's not, you know you made a mistake somewhere along the line. So it's a good way to check your work. Okay? So how many solutions do we have here?
2.
Good. And what are they?
-2 and 4.
Good. So does anyone have any questions about the equidistant property? Okay. So moving on to the next one. I put it into Desmos ahead of time just so we have it ready. So I'm going to show it to you real quick and then I will bring it back over to talk about the points. So you're going to see that when you put it into Desmos, you're going to get a lot of decimals for this one. Because it's...
What happens, like, what number do you put in there to get your number?
Good question. It's kind of one of those things that you have to kind of play around with to work with. So you can put any number you want in there and it will give you an output. But here's a typical thing that I want to mention. You know that your x value is going to be somewhere between -5 and 5 because you want it to be all values that fit on the graph, right? So automatically I know it's going to be somewhere between those. Here you can actually use the vertex, which helps you because see how it's in vertex form? The vertex is 1, 4, so I can put that in the middle of my table. Now what you'll notice is, because this graph is 1/4, if I go every number, see how I'm going every number? See how I get a lot of decimals? Because this graph goes really slowly. So I could actually go ahead and jump and skip do every other number. So instead of going from 1 to 0, I could go to 1 to -1. And instead of going to -1, I can then go to -3. So I go every other number. And it's not wrong to do it the other way, but this just gives you a bigger, broader spectrum of what the values are. So either way you do it, you're going to get the right graph. Okay, there's just different options on how to graph it. So some values I got on the graph were -3, 0, -1, 3, 1, 4, 3, 3, and 5, 0. So see how I did every other because all these middle ones are a decimal? So it just kind of helps save us the time with the graph. My axis of symmetry is right here. At what value?
1.
Good. We connect it. How many solutions do I have?
2.
And what are they?
-3 and 5.
Good. So does everyone see how I got that? Okay. So, can anybody tell me what form is this in? Or what do we need to do to get it into? So it's in poorly arranged standard form, right?
It's supposed to be standard,
Yeah, so I could rearrange it into standard form.
Square minus 2 decimals.
So that's how you would rearrange it to get it into proper standard form. Now I do want to mention that Desmos doesn't really care what form you put it in. It will still accept it and give you the same graph. So good news, but it still is important to recognize standard form. I may ask you to put a quadratic in standard form for a quiz, so please make sure you know how to do it. So with that being said, here's what I have so far. I put in a few values for my table to get some values I know that will fall on my graph, and we'll go ahead and plot those. So I go to -2, 5, 1, 0, 3 or 0, -3, 1, -4, and 2, -3. Now where would my axis of symmetry be here?
1.
There's a lot of ones coming up, huh?
Yeah.
Now that I have my axis of symmetry, I can go ahead and find the values on the other side. So what's my other 0 going to be?
3.
Good. And then I have another point, 1, 2, 3, 1, 2, 3. So if anybody's worried about learning how to use Desmos, the good news is Monday's 4.3 is a little activity on Desmos where you go through and practice how to use Desmos. I had to give you a little background on what we were doing before I had you do it because you do need to know a little bit about quadratics first. So that's why it's not the first activity. But how many solutions are there here?
2.
What are they?
-1 and 3.
Good. Does anyone have any questions for me? All right. Let's go ahead and try the next one. So what form is this quadratic in?
It's in vertex form, which means we already know the vertex.
Good, we do know the vertex. And what is the vertex?
2, -1.
Good. So we're going to plot that. 2, -1. And I know that my axis of symmetry would also have to go through this. Oops. I had it right and then it messed up. So now from Desmos, I have some values. I have the value of 1, -4. And I have the value of 3, -4. So which way is my parabola opening? Where are the arrows going?
Downward.
Good. So can everyone kind of see that? So you can start seeing it. Now the reason we only had 3 points on this graph is because if I tried to do another point, it would have went off the graph, right? So that's why we only had 3. So how many real solutions do we have?
0.
Which means the solutions are?
Imaginary.
Good. Imaginary. Alright, is everyone ready to continue? Alright, I'll take that as a yes. So, this is the kind of question that you might be asked on an exam for this class or on the SAT or ACT. So offhand, you should be able to tell me when you have changing A values, how it affects the graph. So what I did here was I graphed it for you to kind of get an idea, to kind of get like an understanding, and then I will have you try it on your own. So give me a second because I messed it up when I just clicked backwards. Hang on. Alright. So as you can see here on Desmos, I went ahead and graphed the 3 equations in question. The first one is the red one, the second one is the blue one, and the third is the green. So it is a little bit hard to compare them because they aren't on the same axes. So what you can do is you can change the sign of this one to negative so that now they're all below. Because the sign doesn't change the width of the graph, it just changes if it's up or down. Okay, and we're only comparing width here, so we don't care about the sign. So what do you notice about the blue one?
It's the widest.
It's the widest. And what do you notice about the red?
The narrowest.
Good. So can anybody come up to a conclusion with this? Up with a
Like tell you what they are or?
So yeah, from this information, what do you notice about the values? How does it affect the graph?
But I have a question.
Sure.
So if green's run is like more than blue's run, why is green wider?
So here I'll explain exactly why. So you don't care about the sign for width, so we're just going to ignore it. So this one has a width unit of 5. This one is 0.5. And this, if you divide it, is about 0.67. Okay?
Oh, so it's like the divide and not just the run.
Correct. So it's based on which one's number is smallest is the widest. Okay, smallest number is the widest. So which one's the widest again?
The middle one.
Good. So the middle is the widest. This one is second widest. And this one is the narrowest. So does everyone see that? How we got that? Okay. And that's because if you multiply numbers by a small number, they're going to go up very slowly. But if you multiply numbers by a large number, they're going to go up very quickly. Okay, that's the reasoning behind this. So if we look at this one, they now want us to go from narrowest to widest. So I'm going to write these out as approximate decimals. So this is approximately 1.17. You can just do 1 divided by 6. This is approximate or exactly 1.5. And this is 1.4. So which one's the most narrow?
0.7.
The widest is the smallest number, right?
The middle one is.
So the middle is the most narrow. This is the second most narrow.
Yeah,
And-
and then 0.17 is the widest.
Yeah, so they tried to trip you up here by going narrow to wide instead of wide to narrow like the last problem. Does everyone see that? Does anyone have any questions? You have to think about it for a second, but that's the idea. And if you ever get stuck, Desmos can help you as well. You can just check it on Desmos and check your work. All right, so number 13, what is the vertex of this graph? 0, 1. And the axis of symmetry is always the x-coordinate of your vertex, which is 0. Very good. All right. What's the vertex of this graph? 3, 0. Which means that your axis of symmetry is
3.
good. Okay. So to state the vertex, first of all, you have to identify what form is this equation in.
Standard.
Good. This is standard form. That was a really bad. Here we go. So since it's in standard form, we learned previously that we use the formula x equals negative b over 2a to calculate the x-coordinate of the vertex. So what's the a value in this equation? B?
4.
And C?
-3.
Good. So with that information, we're going to plug it into the formula. We've got x equals negative 4 over 2 times 2. So that's x equals negative 4 divided by negative 4, which is
1,
negative 1. So we've simply found the x-coordinate of the vertex. So what do we have to do to find the y-coordinate?
Plug it in.
Plug it in. So we take the equation and we replace all of the x's with negative 1. That comes out to be y equals minus 4 minus 3, which gives us y equals negative 5. And that's our vertex. So any questions about finding the vertex in standard form mathematically? Are you ready to try the next one? Okay. So what form is this one in?
Vertex.
It is in vertex form. This is vertex form in case you forgot. But what's the only thing it's missing?
Okay.
The k. So if we don't have a k, we could add on a what at the end? 0. So we can't add a 1 because 1 would change the integrity of the equation. So we can add a 0, which means that my vertex is what? 5, 0. Remember from yesterday's lesson, you have to change the sign of the h. So that's why it's a positive 5. Alright, everyone feel okay about that lesson? Alright, you have homework which will be due on Monday. Not too long. Most people finished it.